So, let's start from highest common factor. Example. As you all learn about it, I will not explain what is highest, but highest common factor is the biggest number that going into the two numbers. So both of numbers can be divided by. Let's consider, for example, 12 and 48. What will be the highest common factor? How we can find it? Highest common factor is the biggest number that's going into both of them. What is the best way to find that? How you will do it?
You do what you can divide by, like you write everything that you can divide 12 by, and then you do that for 48, like in two different lines, and then you say what's like the highest.
Yes, we can do that, but that will be not the most efficient way. Most efficient way will be to write the factors only of the smaller number. So factors of 12. Factors of 12. What are the factors of 12?
1, 2, 3, 4,
6,
12.
And then you look which of them.
12.
Sorry?
Nothing. How do you know?
So, because 12 can be divisible by 1, by 2, by 3, by 4, by 6. Which of those numbers is also a factor of 48, which is the biggest number?
12. So 12.
So you don't need to list factors of the bigger number. You list factors only of the smaller number. Another example, let's say find a highest common factor of 48 and 48 and let's say 80. 48 and 80. So let's list factors of 48. 1, 2, 3, 4, 6, 8, 12.
We said 10.
We said 10.
Oh, sorry, I was like
12,
48.
20, 12, 16, 24, and 48. Now, let's have a look from the right, which of them will be also factor of 80. Is 48 factor of 80?
Yeah.
No. Out. 24.
No. It's 8.
16.
No.
Yeah.
Yes!
Oh,
16
it's
times
not
5,
eight.
16 times 5 is
Yeah.
80. So highest common factor
Yeah,
between 48 and 80
Yeah.
is 16.
16. So 8 is
Uh,
a factor of 48, which means 6 is a factor of 8.
You know,
Yeah, but because
Makes sense how we did it? Now, lowest common multiple. Again, what is let's say, what are the multiples of 5?
5, 10, 15, 20, 25, 30.
5 times 1,
45,
5,
50,
10, 5 times 2, 5 times 3, and so on.
10,
Yeah.
15, 20,
Now,
25, 30.
when we need to find the lowest common multiple of two numbers. For example, if we need to find lowest common multiple of
5 and 2.
let's say lowest common multiple of 20 and 35. Now, we don't need to write multiples of both numbers. Which number we need to write multiples of? Only highest number. Only of the big. With the lowest common, with the highest common factor, we write factors of smaller number. With lowest common multiple, we write multiples of the bigger number. So will be 35, not multiple of 20, 70, not multiple 20, 105,
140.
Not multiple, then we have 140,
Yes.
which is multiple of 20.
Oh,
Done.
so you do the multiples with the higher number?
We roll multiples only of the higher number.
Yeah.
And look which of them will be also multiple of the smaller number. Make sense?
Yeah.
But you have to do the multiples of the highest number.
Now,
And then
prime and composite number. What is prime number?
Oh,
Like seven.
number
Sorry?
is only divisible by 1 in itself.
Yes,
It's only a
right.
factor of 1.
Prime number is number that has only two factors, itself and 1.
13.
So prime numbers,
7.
by the way, 1 is not a prime number. It's a special number.
Is there a term
1
for
not a prime number. Many people thinking that 1 is not, but because 1 has only one factor. 1. Prime number has two factors. So let's list what's the next prime number? 2. By the way, 2 will be the only one even prime number. Yes. The next prime 3, 5, 7, 11, 13, 17, 19, and so on. Okay, is there any pattern in the prime numbers?
That's 3, 5, 7,
3, 5, 7, 9.
9.
1, 3. There is no 5 here. For example, then it will be next. Next will be 23.
Other than 2, they're all odd numbers.
Yeah, they're all odd numbers, but
just two is only
now, okay, one step there. So, accept these first two numbers, then 5, if you write, you see 6. 5 is 1 less than 6, 7 is 1 more than 6. What is 6 times 2? 12. Right, 12. You see 11, 6 times 2. 11, 1 less, 13, 1 more. 6 times 3.
18.
18. 17, 1 less, and 19, 1 more. Then we have 24, 6 times 4. 23 is 1 less. But 25 is not a prime number. But all prime numbers
29.
are 1 away from multiple of 6. All prime numbers are 1 away, 1 less or 1 more than multiple of 6.
What about 3?
No, except I'm saying except these first two.
So
After that,
There's still 4.
any so
what's like 49 or 47?
49 is not a prime. 47 is 48
Yeah.
minus 1, and 48 is a multiple of
Prime
6.
and it's one of the yeah, I know.
Yeah.
Why is it
It's not necessary both of them will be prime numbers, but all prime numbers 1 away of multiple of 6. So that can help you to identify prime numbers. Now, composite number. What is composite number?
That's not a prime.
Has that more than 2
So
factors.
it's just not.
And we have a look into the prime factorization now as well. So, let's say, let's take number 48. It is clearly not a prime number. And let's find all prime factors that called prime factorization. So 48 divided by 2.
24.
And 2 is a prime number. 48 divided by 2 is 24. Is 24 prime? No.
2 and 12.
Divided by 2. 12. 2 is a prime number, we stop here. 12 is not.
4 and 3.
So we have 2. We can do 4 and 3, but let's 2, 6.
Like, is that what
2,
composite?
3. No, composite numbers.
Composite number is 48 because it has more than 2 factors. composite which has more than two factors.
That's how you find it.
This is how you find the prime factor.
This is a prime factorization. So B, write this down, write this example down. Write this example down.
So the prime factorization of 48.
And all example, I expect that you all example that I write on the board you copy.
Okay. Oh wait, what?
They copy those examples. So that is prime factorization. It is prime factorization. Prime factorization and the building factor 3 to find prime, to do prime factorization. Warning. Next time you do. So that's how we build factor 3 and finding prime factorization. So we stop as soon as we get to prime number, we stop.
Wait, so when you do that, do you do the smallest and the largest one?
It doesn't matter. The main thing you stop. You can do this, for example, you can do 3 and 16. Then you do 2, then you do, for example, you can do
4 and 4.
let's do 4 and 4, and then 2, 2, 2, and
The same
2.
answers.
And we end up at the end. What we have here at the end? How many 2's we have?
4.
So that's equal 2 times 2 times 2 times 2 times 3. In this way we get the same. We have 4 2's, 2 times 2 times 2 times 2 times 3. It's not necessary to do this way. Anyway, you can do anyway. Huh? We stop when? When we get to the
Wait,
prime
why is
number.
there a 3 for that
You
one?
just stop when you
Three
get to
is
a
either
prime.
opposite
Oh, because there's a 3 at the, oh yeah.
Okay, we can do both then.
It's that's just two ways of do the same thing.
Yeah.
And that called factor 3, and in this way we did prime factorization. We found prime factors. Prime, they're all prime numbers. There's no composite number. So if question is find prime factors of the number, what you need to do to make a factor 3.
Could you? Like 4 times 12.
Yes,
Good, clear.
you get 4, 12, 2, 2. How you want? 12, 6, 2, or 3, 4. What do you want? 3, 4,
2, 2.
2, 2. Again, we
You get
get
the same result.
at
That's
the
really
end, we get the same 4 2's and 1 3. Anyway, works. As soon as you stop, only when you get to the prime number. You keep building 3 until you get to prime numbers. Make sense?
Yeah.
Okay, now, square. What does it mean if we write
But what's composite numbers?
composite number which has more than 2 factors? For example,
Anything that's not
9 is a composite number because 9 has factors,
6.
factors 1, 3, and 9. Because 9 can be 1 times 9, but also 3 times 3. 7, which is prime number, can be only 1 times 7. This is a prime number. This is composite number.
I just don't care.
Make sense? Now, square. If we write, let's say, if I write 5 squared, what does it mean?
5 times 5.
5 times 5.
5
5.
times 5,
25.
which equals 25. If I write 10 squared, what does it mean?
10
times
times
10.
100.
10 times 10 equals 100. Now, if I will write,
Cube.
let's say 5 cubed, 5 in the power of 3 equals 5. 5 times 5
100.
times 5, which is 125. If we'll write, let's say, 4 cubed, will be 4 times 4 times 4 equals 64.
And the square root of 64 is 4.
Square root is an opposite operation. So if you need to find, when I have a question, square root of 16, what this question asks you?
Square root.
What
Yeah,
again?
but
What
what-
times God equals 16?
Yes,
What
which
times
number
itself?
times
Times
itself
itself.
equals 16.
Four.
And it is equals 4 because 4 times 4 equals
Like the
16.
square root. Oh, so the square root of 25 is 5. Ah.
Just the opposite.
What will be, and clear, yeah? Okay, please tell us what will be square, everyone shush please, square root of 64. Good. What does it mean? That 8 times 8 equals 64. Good. Now, cubic root. When question asks cubic root means find number which multiply by itself 3 times equal what is under cubic root. So if we have cubic root and we write it like this as a square root but we put 3 here, cubic root, let's say, of
120.
8. What question asks which?
2.
Yes, it's equal 2 because 2 times 2 times 2 equals 8. Cubic root of 64
4.
equals 4.
It's just what the square root is divided by 2. So because the square root of 64 is 8.
Divided by 2.
So the cubed root of 64 is 4.
Now do 8.
What was that then? What's that? What's square root of
It
8?
doesn't work for other numbers.
Oh.
For example, 3, let's say, what is cubic root of 27? What is cubic root of 27?
9. No.
No.
Which number multiplied by itself?
3.
Three.
3.
3. It is 3 because 3 times 3 times 3 equals
Oh, true. It's
27.
6 times. Yeah.
Yeah. So what you say does not work in general for one particular case. Hmm? Makes sense what is cubic root?
Yeah.
Okay, now prime factorization. Then last thing, divisibility. We can find if one number is divisible by something without actually performing division. Not always, but for one-digit numbers there are certain rules. What is the rule of divisibility by 2?
Has to be even.
Last digit has to be even. So if we have number is this number divisible by 2?
Yes.
Yes. Because we don't care what is here. We care only about the last digit.
So it
If
just has
last,
to end, it has to be even.
Yeah.
if last digit is even, number is divisible by 2. Yes.
So also if it ends with a 0 or 5, it's divisible by 10
By 5.
or by 5.
5. Yeah, we will come to that in 2
What
minutes.
is it by 5?
No.
5, 10,
By 5.
Oh yeah.
Now, divisibility by 3. How we decide if this number divisible by 3 or not, without actually doing division.
It has to be multiple.
No?
Yes,
We
have
need,
one there.
how we work it out?
It's a trick. I don't know. The trick.
We add all digits. We need to
Oh, yeah.
add all digits. 1 plus 2 plus 5 plus 7 plus 3 plus 0 plus 4 plus 3 plus 2. We have 8, 15, 18, 22, 21, 27. To find if number divisible by 3, we just add all digits. When we add all digits, we get 27. Is 27 divisible by 3?
Yes.
So this number is divisible by 3.
Yeah.
So to find if number divisible by 3 without doing division, you add all digits. If the result divisible by 3, the whole number divisible by 3. Now, divisibility by 4.
It has to be like a.
When it was divisibility by 2, we were looking only on the last number. If it's divisibility by 4, we look on the last 2 digits. If 32 divisible by 4?
Yes.
Yes, 32 divided by 4 is 8. If last 2 digits divisible by 4, the whole number divisible by 4. So you don't need to do division to answer if number divisible. You look on last 2 digits. Make sense?
Yeah.
Divisibility by 5.
We say 5 or 0.
Yep, divisible by 5. If last digit 0 or 5. If it ends by 0 or 5, it's divisible by 5. So is this number divisible by 5?
No.
No, it does not end by 0, it does not end by 5. Divisibility by 6.
4.
If number divisible by 2
If it's divisible.
and by 3,
I was gonna say.
if it's divisible by both, by 2 and by 3, it's divisible by 6. Now you have a question? No?
Also,
So, is this number divisible by 2?
Yes.
Is this number divisible by 3?
Yeah.
Yes.
So, is it divisible by 6?
Yeah.
Yes.
Yes. It has to be divisible by both. If it's divisible only by one of them, it's not divisible by 6. Make sense?
Yeah.
Because 6 is 2 times 3. Yeah. Now, divisibility by 8. Divisibility by 8, we need to look into the last 3 digits. If last 3 digits divisible by 8, the whole number divisible by 8. So, can you divide 432 by 432 by 8?
3.
Wait, is 8 the last 3 digits?
For 8, we look for last 3 digits, so by 8, we do
Yes.
432 divide by 8, what it's equal?
84.
Not 80.
4. Wait, no.
450. Okay, I can do that.
54.
54, yes, 54. 54, well done. So, as last 3 digit divisible by 8, the whole number divisible by 8. And the last rule that you're supposed to know, this table is in the booklet, and you're supposed to learn it. By 9, again we add all digits, as we did
So yes.
for 3. We need add all digits. And the result 27. Is 27 divisible by 9?
Yes, 3.
So this number is divisible by 9. So same rule as for 3. We add all digits.
So if it's divisible by
If the result divisible by 9, then the whole number. Yeah? Okay, now 7.
Wait, by 8.
By 8, last 3 digits. If last 3 digits divisible by 8, the whole number divisible by 8. Now, the next rule you don't need to know. Divisibility by 7. It's very complicated, and it's not included in any books, because it's much more complex than all those, but I'll give you an example. Let's say number 2531. How we can decide if it's divisible by 7? This rule and what I'm explaining by the divisibility by 7, you don't need to know. But I thought it might be interesting. We take the last digit and take it away. Then we multiply 1, multiplied, we double it. We double last digit and we minus from here, minus 2. 251. Then we do the same thing with 251. We take last digit away, so 20, and we multiply it by 2, and we minus by 2 equals 23. And then we do it again. Then we just take away last digit and see what we left. If result, last digit which left is 0, if last is 0 or 7, number divisible by 7. If 2, not divisible by 7. You don't need to know this rule. You see it's quite complex. We need to take one digit at a time, work with it, but still there is a rule for divisibility by 7. We remove the last digit and we double it and we minus it from what's left. And we continue this process until we will left with one digit. If that last digit that's left is 0 or 7, number divisible by 7. But again, this is well beyond the school program. Okay, that's the whole theory for today. It was a lot. And that's why.
Wait, did you teach us prime factorization?
Yeah, that's a tree thing.
Yeah.
Factor
That's
tree.
right.
So, what you need to start working on is from textbook 1C on the page 17, questions 1 to 6, 9 to 11, and 14.
Wait, so what do we do in the booklet?
That is not booklet, not that from the textbook, you're doing it in your workbook. And also, you could see, if you look on CLE, you will find that question 15, all those numbers in black. 15 is in green. What does it mean? That this is extension question. You don't have to do it. I encourage you to try, but it's a harder question that is not compulsory. If some number on CLE is in your what you need to do is in green, that means it's extension question. You don't have to do it, you're not compulsory, but it's good to try. It's a harder question. Now, also from now we start doing questions from booklet and questions from pages 4 to 7. Now, when it's due, actually stop the video.